You want to know a secret? 2 videos ago when I test drove this car, it only kind of worked.
I couldn't shift gears. I had no instrumentation, and I couldn't drive very long for risk of overheating the inverter. I didn't lie in the video, I just kind of left that part out. I want to be able to push this car as hard as anything being made by big name brands. I want to be able to clutch kick and break the tires loose. I want to be able to slam my foot down on the pedal and not worry about overheating. I want to be able to enjoy this car as much as possible.
I got that just right.
But there's still some missing pieces.
So now it's time to fab up some shift linkages, program some gauges, and plumb a coolant loop.
To start moving from a standstill, you don't have to be in first gear. Mine's been sitting in second since I got it moving. And since I can't shift yet, it also means when I put it in reverse, I'm reversing the motor, not the transmission. So I'm driving backwards in second gear. For now, when I do need to shift, this is how I do it. I do have a convertible top, but it's not exactly practical to do this while going 50 miles an hour. This is how the shift linkage looks from factory, and this is how my EV looks. The batteries are completely blocking the path. I know I can come up with a solution using shifter cables, but I have no idea how to go about this. All I know is that through brute force and raw willpower, I will figure out a way. I'm not an engineer. I'm also not the YouTuber, not an engineer.
I'm not an engineer.
But I wonder if I were an engineer, would there be an obvious way to go about this? Here's how I'm looking at it. The transmission has 2 arms to it. One makes horizontal movement and the other makes vertical, so 2 shift cables. And I need some variation of a belt crank bracket per input. To have some idea what I need to replicate, I went to my friend Mike's house. He also has a Scorpion. His brother is who I bought mine from. He went through the gears and I recorded their position. For the shift lever in the cabin, I already have what I'm going to use. This is out of a Toyota MR2,
Mr. 2 if you're nasty.
which is also a mid-engine car, but this one used shift cables from factory. I need to invert the movement though, so that when I push forward on the lever, it pulls back on the transmission. Here's what I came up with for the mounting brackets, and here's where it fits. This took a few iterations to get it right, and the 3D print material is great for prototyping, but you can't actually shift without breaking it. This will work though. And a week later, we get it from Sencut Send. A few quick welds, 1 complete redesign, and you can see the inverted movement and the 2-to-1 reduction. We're in business. So what's next? Electrical programming is monotonous work. It's even more dull to watch a video about someone doing it, so I'll spare you the details. But I need to connect my instrument display to my EV components. It can really drag on, and you feel like you're starting to lose your mind. And then you're done, and you have a functioning display. Right now it's just raw data outputs until I fully tune the car. There's this quote by Abraham Lincoln. I don't know if he really said it, but everyone gives him credit for it anyways. It goes, if I had 1 hour to chop down a tree, I'd spend 50 minutes sharpening the axe. That was my approach to planning out the cooling system for this car. I spent about a week planning it, and by that logic, you'd think I'd only spent a day connecting it all. I wish I could say that was the case. The inverter, which is kind of like your ECU, typically needs some form of active cooling. The batteries don't necessarily need it, but cooling them extends their life and the scale on how hard you can push the car. So I'll be cooling both. For the radiator, there's this perfect spot for it in the front of the car. And why is it perfect? Because that's where the factory radiator went. Using this spot also keeps me from having to reinvent the wheel with all new plumbing. The coolant loop will go pump, radiator, batteries, inverter, reservoir, and then back to pump. I'm doing a single loop as I don't expect the batteries to need the cooling often enough to justify 2 separate loops. Hitting the batteries first, as they'll be less hot than the inverter. Doing this backwards could be disastrous and heat the batteries with the hot inverter coolant. I'm concerned about localized hot spots in the batteries, but I think I can mitigate that with a vacuum fill and bleeder points above the battery box. I'm not sure if cooling the batteries will work, but I've already went through the huge pain of plumbing the battery box and designing the internal spacers to accommodate the coolant hosing. I pressure tested those hoses too. And I'd like to be able to take some pride in accomplishing something most conversions avoid out of difficulty. And it's after this little humble brag and buying a new radiator that I realize an issue. The original coolant lines are about 1.25 inches in diameter. The inverter ports are about 1/8 of an inch. So to go from the radiator to the inverter is a 90% reduction in size. That just won't work. Okay, so new plan. I still want to cool both parts, so we're going to do 2 independent loops now. Both loops will get their own radiator, pump, expansion tank, and the batteries loop will get a proper radiator pressure cap because of the volume of liquid. Not needed in the inverter loop because the air in the expansion tank will be enough to compress the lower volume of coolant. The inverter loop is pretty straightforward, but the optional battery loop has to have the components arranged properly for it to be effective. The tank needs to be the highest point of the loop, but it also needs to maintain an air gap. The straw must be at the bottom to pull the coolant without the risk of bubbles. I also need to make mounting brackets for the radiators. Actually, you know what? Let's do something different. Instead of the surface level overview of everything, let's deep dive into what the day in the life of working on a car is really like.
Hey, don't forget, you gotta pick up the girls at 3.
Okay, it's what, 11 o'clock now? 1, 3, 4, 5, plenty of time, no worries. Okay, let's get this cardboard template going, and it's way too flimsy, this thing sucks. Okay, let's mark the holes for where I need to drill, and wait a second, what the hell is this? We need some sort of vibration dampener. Let's drill these holes real quick. Okay, that's kind of weird, it doesn't fit. Could that take care of back plenty of time? Okay, that ate into my time a little bit, but we're doing all right. Yeesh. Okay, let's go. 3D printer on. Where is it? Riv nut. There we go. Perfect tool for the job. Okay, same problem as the drill. It doesn't quite fit at the right angle. Keep that sauce stirring. Don't let it burn. First time I've had to downgrade a tool before to make it work. Are you kidding me? Alright, we can still make this work. I don't have time to run back to the store. Let's get this off here and let's get these washers on, and maybe that'll be just enough. Okay, we got about an hour left. How's the 3D printer going? Is it working? And yes. Okay, now we need to make the brackets. Let's see, I know I've got some angle iron that'll work good for the brackets. We need, gotta drill it, sand off the edges of the 3D printer. Oh yeah, we're good. I don't have enough time. Where are the screws? They're right here a second ago. That's not them. Where did I put these damn screws? Oh my god, I'm losing my mind. Okay, got the screws, let's go. Let's get these brackets on just in time. Let's get these off. And, oh, are you kidding me? I forgot I'll get these little spacers in there. Home stretch, come on. Just work with me here. All right, and I think we're good. You know what? Not a bad day's work. And, yeah, we got plenty of time left over before I gotta go pick up the kids. Like 10 minutes. And after all this work, I'm still not sure if it'll function properly, but it's time to test it. Alright, so first attempt was a failure. My little toy air compressor wasn't up to the job, and I spent another 2 days trying to siphon out the air from the lines. My new compressor is more than capable, and we're ready to go. The coolant I'm using is G48. It's non-conductive. You certainly don't want any of it to spill in the battery box, but if it were to happen, it'd have a low chance of creating a fire. The pumps are connected to temp sensors, but I also have a manual switch. Both the pumps are running, and I don't see any leaks. This is a good sign. I think it's time to take it for a test ride. Okay, that was a short test drive. The motor's cutting out. I'm not sure if it's heat or voltage sag, but I'm sitting in the shade now, letting the car cool down a bit before I take it home. Okay, so we looped it home, and I think I figured out the issue. Basically, all these cables are way too loose. I think at one point I finger tightened them and then never came back and torqued them down. We got the main fuse here and then the maintenance switch. It's basically like pinching a straw and trying to drink through it. I can't say for certain if that's the issue, but we'll tighten it down, and then there's only one way to find out. I spent over 3 months learning and practicing TIG welding to make the battery box. After 3 weeks on the lathe, I had to start over on the motor coupler. Night after night, I was up past 1 a.m. when I was first running all the wires to get the motor to spin. I put 708 hours on my 3D printer. That's 30 days, and I probably spent triple that amount of time in CAD designing parts. There are definitely easier ways to do an EV conversion. I did it all from scratch because I wanted to fully understand what goes into each component. But also, had I taken the easy route, that smile on my face would be just a little smaller. We didn't get the clutch kick or the donuts yet, but the car's sturdy. We'll get there soon. Thank you for watching.